Hello all, my name is Sammaish. I am a teacher by profession. We know that the task of a communication engineer is to design a communication system for error-free transmission of data. I also try the same by making most of the solution should be error-free, and I had given all of the solution with the best of my knowledge. And the mode of the coming demonstration is to avoid the ambiguity in the communication solutions. Memoryless source has an alphabet small a1, a2, a3, a4 with the corresponding probabilities 1 by 2, 1 by 4, 1 by 8, 1 by 8. The minimum required average code word length in bits to represent the source for error-free construction is. For the error-free construction from the source code theorem, if the source has n number of symbols, here it is a number of symbols, the source consisting of n number of symbols, and n I should be the number of bits to represent an ith symbol, then it has to satisfy the Croft inequality. Croft's inequality, that is summation I equal to 1 to n 2 power minus ni must be less than or equal to 1. This is called Croft's inequality. To satisfy the Croft inequality, suppose if I denote capital L is the average code word length, and capital H of x is the entropy of the source, capital X. Then to satisfy Croft inequality from the source coding theorem, to satisfy the Croft inequality from the source coding theorem, this average code word length always greater than or equal to entropy of the source, so that the minimum average code word length to represent source for error-free transmission L minimum equal to H of S, that is the entropy of the source. Here the source has 4 symbols A1, A2, A3, A4, and the corresponding probabilities are 1 by 2, 1 by 4, 1 by 8, 1 by 8. Then the entropy of the source is, it is a summation I into pi into log of 1 by pi, where pi is the ith symbol transmitted probability. So here it is given, it is 1 by 2, 1 by 4, 1 by 8, 1 by 2 of symbols A1, A2, A3 and A4. So that entropy H of x equal to it is 1 by 2 into log base 2 plus 1 by 4 log 4 base 2 plus 1 by 8 log 8 base 2 plus 1 by 8 log 8 base 2. So this is 1 by 2 plus 1 by 2 plus 1 by 8 log 8 base 2 means it is 3 by 8 plus 3 by 8. This is equal to 1.75 bits per word. So for every word or symbol has to be encoded with 1.75 bits per word. So this is the answer is 1.75. It generates a binary sequence alpha n. Alpha n can take one of the two possible values -1 and +1 with equal probability and are statistically independent and identically distributed. This sequence is procoded procured to obtain another sequence beta n as beta n equal to alpha n plus k into alpha n minus 3. The sequence beta n is used to modulate pulse g of t to generate the baseband signal capital X of t is summation n equal to minus infinity to infinity beta n into g of t minus nt, where the pulse g of t equal to 1 over 0 to capital T and 0 otherwise. If there is a null at f equal to 1 by 3t in the PSD of capital X of t, then capital K is. This is the one of the fantastic question that was given in the GATE 2006. Now we will step by step we follow. And for a baseband signal capital X of t, the power spectral density of capital X of t, S of f equal to, it is mod of capital G of f whole square by t, where G of f is the Fourier transform of the pulse, multiple with summation m equal to minus infinite to infinite r beta of m into e power j 2 pi m f capital T, where r beta of m is the autocorrelation function of the random sequence beta n. Autocorrelation function of the random, it is beta n. Now step by step we follow the autocorrelation function you would like to find out, that r beta of m equal to, it is expectation of beta n and beta n minus m, and this is equal to, it is expectation of, what is beta n? It is alpha n plus k into alpha n minus 3 into alpha n minus m plus k into alpha n minus m minus 3. This is equal to, here alpha n minus m, so the difference should be m, and here this, so you will get the simplification of this expression will get 1 plus k square into r alpha of m plus k into r alpha of m minus 3 plus k into r alpha of m minus 3, where r alpha m is the autocorrelation function of the sequence alpha m. Now we will find the autocorrelation function of the binary sequence alpha n. Here the alpha n contains to minus 1 and plus 1. The autocorrelation function of r alpha of m equal to, it is expectation of alpha n and alpha n minus m, and this is equal to summation I equal to 1 to capital I and alpha n and alpha n minus 1 of ith combination into the probability of that ith combination. Now for m equal to 0, there are two possible combinations. When m equal to 0, this is alpha n into alpha n, so that if this is 1, this is also 1, this is minus 1, this is also minus 1, so that there are two possible combinations are existing, and each and every possible combination has a probability 1 by 2, so that r alpha of m equal to, it is otherwise the expectation of alpha square. So this is 1 whole square into 1 by 2 plus minus 1 whole square into 1 by 2. So this is equal to 1. And for m not equal to 0, r alpha of m, for where m not equal to 0 means the signal and that adjacent one and the signal one and after 2 units, so that there are 4 possible combinations are existing. If the present sequence has a value minus 1, then the shifted value might have plus 1 or might have minus 1, so that 2 possible combinations exist. Suppose if the present sequence is at plus 1, then the shifted version of the signal might be plus 1 or minus 1, so that 4 possible combinations are existing, so that the summation I equal to 1 to 4 into alpha n minus 1 into pi, so this is equal to minus 1 into minus 1 with the probability 1 by 4 plus minus 1 into 1 with the probability 1 by 4 and plus 1 into minus 1 into 1 by 4 and plus 1 into minus 1 plus 1 into 1 by 4. So this is equal to 0. So that the autocorrelation function of alpha, which has a value 1 for m equal 0 and which has a value 0 when m not equal 0. By substitution of these values in the autocorrelation function of beta, then r beta of m equal to 1 plus k square when m equal to 0 and 1 plus k for m equal to 3 and this is m plus 3, okay, and equal to k for m equal to minus 3. So this is the autocorrelation function, and 0 otherwise. Now this values, the autocorrelation function, we have to substitute in this definition. Now okay. The power spectral density at 1 by 3t equal to mod of g of 1 by 3t whole square by capital T summation minus infinite to infinite r beta of m into e power j 2 pi m into 1 by 3t into t. This is equal to 0. And what is if g of t as a pulse, if g of t has a value from 0 to capital T which has a value 1, then the Fourier transform of this capital G of f mod g of f whole square, then you will get it is equal to t square into sinc square ft. So 1 by t and 2 by t, 3 by t minus 1 by t minus 2 by t. So at f equal to 3 by 2, at f equal to 1 by 3t, the mod g of f value cannot be 0. So that this second term must be 0 in order to make the power spectral density at f equal to 1 by 3t equal to 0. So the substitution of these values, therefore summation minus infinite to infinite r beta of m into e power tt cancel e power j 2 pi m by 3 equal to 0. Then this is equal to, this implies 1 plus k square into exponential of j 2 pi 0 by 3 plus k into e power of j 2 pi 3 by 3 plus k into e power of j 2 pi minus 3 by 3, and remaining all other values should be 0. So this is equal to 0. This implies 1 plus k square in plus k into e power of 2 pi. E power of 2 pi is nothing but 1 plus, and e power of minus 2 pi is nothing but 1. So this is equal to 0. This implies 1 plus k square plus k 1 plus 2k plus k square. So that 1 plus k whole square equal to 0. This implies k equal to minus 1. So that the value of capital K which make the power spectral density of capital X of t at f equal to 1 by 3t is 0 is k equal to minus 1. A speech signal is sampled at 8 kHz and encoded into PCM format using 8 bits per sample. The PCM data is transmitted through a baseband channel via 4-level PAM. The minimum bandwidth in kHz required for transmission is, the transmission bandwidth required for M array PAM, for M array PAM case, the transmission bandwidth is required, the transmission bandwidth is required greater than or equal to RB by 2 into log m base 2, RB by 2 into log m base 2. So the minimum transmission bandwidth is required is it is RB by 2 into log m base 2, where RB is bit rate, and m is the MRA, that is MRA level, that is m is number of levels, and here that RB should be equal to NFS, bit rate equal to N into Fs, where N is the number of bits per sample, and here this is Fs is the sampling rate, it is samples per second, so you will get RB should be bits per second, that is bit rate. N is the bits per sample and Fs is the sampling rate, that is samples per second within 1 second, and so RB is bits per seconds, and the number of bits which is given 8 bits per sample, and the sampling, it is the speech signal sampled at 8 kilohertz, so that it is 8k, so that it is 64 kilo bits per second. So the minimum transmission bandwidth equal to 64k by 2 into log of, it is f level, it is 4 level, it is 4 base 2, so it is 64k divided by 2, log 2 base 2 is nothing but 2 into 2 4, it is equal to, it is 16k. So already the professor was it is given in the brackets, it's kilohertz, so that answer is simply 16, that is the bandwidth equal to 16 kilohertz, so answer is 16. Consider a random process capital X of t equal to 3 into capital V of t minus 8, where capital V of t is a 0 means stationary random process with autocorrelation function Rb of tau equal to 4 into e power minus of mod tau. The power in capital X of t is, here power in capital X of t is, the power in capital X of t is expectation of x square of t, the mean square value of the random process, the mean value which gives the power in x of t. So this is equal to expectation of, what is the x of t? It is given, it is 3 into v of t minus 8 whole square. Then by using the a minus b whole square formula, then you will get expectation of 3 into v of t whole square, you will get 9 into v square of t and 2 minus 2ab. So 8 3 24, 24 into 2, it is 48 into v of t, and plus 8 whole square, it is equal to 64. And the expectation is a linear operator, so that this expression you can write as 9 into expectation of v square of t minus 48 into expectation of v of t plus 64. Of course, I am writing one more step, expectation of 64. Now expectation of v square of t, the mean square value of the random process v of t, nothing but the power that is present in v of t. And we know that the autocorrelation function Rv of t, it is a stationary, it is given, it is a 0 mean stationary random process, it is expectation of v of t into v of t plus tau. Why? Because the professor is given, it is a stationary random process, so autocorrelation function expectation of v of t into v of t plus tau. So Rv of 0 equal to expectation of v of, when substitution of tau equal to 0 here, then you will get Rb of 0 equal to expectation of v square of t. And what is Rb of tau? It is 4 into e power minus t mod tau. This implies the expectation of v square of t equal to, it is 4 into e power of minus 5, 0. This is equal to 4. And substitute this value here, then 9 into, it is 4 minus 48 into expectation of v of t, it is a 0 mean, so that the mean value of the random process is 0, so 48 into 0, and expectation of a constant is constant, it is equal to 64, so 36 plus 64, it is 100, so that the power that is present in capital X of t is 100, so answer is 100. Communication systems makes use of the symbols 0 and 1 there are channel errors, consider the following events. Small x0, a 0 is transmitted, small x1, a 1 is transmitted, small y0, a 0 is received, and small y1, a 1 is received. The following problems are given. P of x0 equal to 1 by 2 and P of y0 by x0 equal to 3 by 4 and P of y0 by x1 equal to 1 by 2, and the information in bits that you obtained when you learn which signal has been received while you know that a 0 has been transmitted is. So based on the data, I am pictorially representing that channel, the communication system. Here in the transmitted part, there are two events are happening. One is a 0 is transmitted, which is denoted with a x0, and another one is a 1 is transmitted, which is x1. And in the receiver part, there are two events are happening. One is a 0 is received, which is denoted with y0, and a 1 is received, which is denoted with y1. And it is given the problems are given P of x0 equal to 1. That means the 0 transmitted probability at the transmitted part is given P of x0 equal to 1 by 2, and P of y0 by x0. What is the meaning of this? It is in the receiver which is received as 0, when it is transmitted symbol is 0. That is P of y0 by s0, P of y0 by x0. This is given as 3 by 4. And the next probability is given, it is P of y0 by x1. This is in the receiver which is received as 0, when it was transmitted bit is 1, that is x1. So probability of y0 by x1, probability of y0 by x1 is given, it is 1 by 2. Probability of y0 by x1 is given, it is 1 by 2. Now the question is, the information in bits that you obtain when you learn which symbol has been received while you know that a 0 has been transmitted. That is, we know that x0 is happened. X0 is happened means the event x0 is happened. That means a 0 is transmitted. Now a 0 is transmitted, then what is the information of received symbols is, it is h of y capital Y by x0, h of capital Y by x0. Here where capital Y is set of events and the receiver section, that is which consisting of what, two events y0 and y1, and h of y0 by x0 is equal to, it is probability of y0 by x0 into log of 1 by probability of y0 by x0 plus probability of y1 by x0 into log of 1 by probability of y1 by x0. That is, when you are transmitted 0, already it was given there are errors in the channel, so that it cannot be reached as 0, which might be reached as 1, and if you are transmitted 1, which is as 0, but here it is given 0, so that there are two possible cases. This x0 is received as y0 or x0 is reached as y1, and if x0 is reached as y0 with the probability 3 by 4, then x0 is reached as y1 is 1 by 4. That is, the probability of y1 by x0 equal to 1 by 4. So that the conditional entropy of the receiver h of y0 by x0 is equal to probability of y0 by x0, it is given, it is 3 by 4 into log of course here it is base equal to 2. Why? Because the professor is asked in terms of bits, so that in the entropy the base is always 2 if it is bits. Log of 4 by 3 plus log of 4 by 3 plus P of y0 by x0. P of y0 by x0 is 1 by 4. It is log of 4. This is equal to 0.811 bits. So answer is 0.811. An ideal bandpass channel 500 Hz to 2000 Hz is deployed for communication. A modem is transmit bits at the rate of 4800 bits per second using 16 QAM. The rule of factor of a pulse with a raised cosine spectrum that utilize the entire frequency band is. Here the channel, an ideal band pass channel, which is 500 Hz to 2000 Hz. 500 Hz to 2000 Hz. 500 Hz to 2000 Hz. Now I am drawing a diagram for this, for an ideal band pass channel, which is 500 Hz to ideal means which is a constant, might be some 500 Hz to 2000 Hz. I am drawing only positive spectrum, not the negative portion. The negative portion should be symmetric with respect to this, and this is the channel spectrum. And now we are using the raised cosine pulse with a raised spectrum that we are utilizing the interband of frequencies by using a 16 QAM. 16 QAM. Now a raised cosine pulse which has a rule of factor equal to alpha, which is using the pulse width of this, and then the transmission bandwidth of the 16 QAM, that is generally for MRA QAM, the BT equal to, that is the transmission bandwidth equal to RB log n base 2, minimum transmission, RB log n base 2 into 1 plus alpha when we are using a raised cosine pulse. And so this transmission bandwidth for QAM, which has to utilizes the entire frequency band. That means this BT equal to the transmission bandwidth of the signal QAM. This is the transmission bandwidth of the signal, not channel. The transmission bandwidth of the signal, minimum transmission bandwidth of the signal of MRQM. This BT equal to the channel bandwidth BC. Suppose if you consider the channel bandwidth equal to BC. And what is the channel bandwidth? It is the band pass channel, so the channel bandwidth BC equal to, it is 1500, 2000 minus 500. So this implies, why? Because the professor is given that utilize the entire frequency band. That's why the transmission bandwidth of the signal equal to channel bandwidth. So RB by log m base 2 into 1 plus alpha equal to the channel bandwidth is how much? 1500. The bit rate. So given RB equal to 4800 bits per second and M equal to 16. This implies 1 plus alpha equal to 1500 by RB is 4800 into log n base 2. So log 16 base 2. This is equal to, it is 15 by 48 into, it is 4 and 412. It is, this implies 1 plus alpha equal to 5 by 4 and alpha equal to 1 by 4, so that the rule of factor equal to 0.25. Rule of factor equal to and average this year ISC Bangalore is given 10 questions from communication system for each and every paper, and most of the questions are simple and formula substitution, and some of the questions are concept oriented, but always preparation is formula orientation is not at all failed. You have to always prepare the subjects with some conceptual intuition and prepare more number of concepts rather than solving more number of questions on the same concept. And especially for the communications, you read most of the concept from the probability and random process. Why? Because that subject should be the basis for the communication systems. Once you have get some idea and familiarity in the random process, the solving of the question from the communication systems is very simple. It is generally in most of the questions you can able to solve 3-4 steps only. It's not a big task, but it requires some mathematical background of the probability and random process. And apart from that, I would like to tell you, you have to practice unsolved question of some standard books. It might be the communication systems by Prokis or Simon Akin or BP Lathi. So which book you are following in your graduation, but you have to solve all the unsolved questions that was given an exercise. Okay. Okay, catch. While learning the concept, you must be clarity about the concept. Rather than getting more information regarding the concept, you must be clear cut about the concept. Each and every term you must be clear. And my dear friends, and you must be practice. That means revise. It is most important thing. It's not only the communication system subjects. For every subject, revise is most important thing. When you are properly planned for the revision, then you will get a very good marks in the communication systems. And all the best and best of luck. And if you have any doubts regarding these solutions or any communication systems doubts, you might mail me to my mail address, that is Sam Gupta 005 @gmail.com. SAMGUPTHA 005 @gmail.com.